Hi everybody. So in this video I'm going to show you how we can multiply with complex numbers in modulus argument form. So if we have two complex numbers, let's say z1 and z2, each given in modulus argument form, we're going to multiply these two together. So if we have z1 multiplied by z2, what this will be, so I'll expand this out. So r1 cos theta 1 plus r1 times I sine theta 1. And this will be multiplied by z2. And we'll expand this out. So we'll have r2 cos theta 2 plus r2 and then I sine theta 2. So what we need to do is we need to expand out these pairs of brackets. So z1, z2 will multiply the r1 cos theta 1 by the r2 cos theta 2. So we'll have r1, r2 cos theta 1 times cos theta 2. And then we need to multiply this term by this term. So we'll have r1, r2 times the I cos theta 1 sine theta 2. And then we'll move on to this term multiplied by these two. So we'll have r1 I sine theta 1 multiplied by r2 cos theta 2 plus this term multiplied by this term. So r1 I sine theta 1 times r2 I sine theta 2. Okay, so we multiplied that with two pairs of brackets. Now we can simplify this by collecting the real and the imaginary terms together. So if we underline this real term in purple, and this is also a real term, because what we have is this I times this I, and together they make I squared, which we know is -1. So we can simplify the real terms. We'll have r1, r2 cos theta 1 cos theta 2 minus, we'll multiply these r1 and r2, so minus r1, r2 sine theta 1 sine theta 2. And then the imaginary terms will be this term, because we've got an I here, and this term, because of this I. So we'll factor out the I, and we get plus I. Then for this term, we have r1, r2 cos theta 1 sine theta 2 plus this term, r1, r2 sine theta 1 cos theta 2. Okay, so we've got the real parts and we've got the imaginary parts. Now we can simplify each of these parts using the addition trigonometric formulae. So we have these addition formulae, and can you see that if we have cos of alpha plus beta, well, this is exactly the same as the real part of our complex number, where alpha would be theta 1 and beta would be theta 2. So we can write the real part then as r1, r2 multiplied by the cos of theta 1 plus theta 2. And the imaginary part is exactly the same as the sine addition formulae, where alpha would be theta 1 and beta would be theta 2. So this would be plus I r1, r2, put this in brackets, multiplied by the sine of theta 1 plus theta 2. Okay? And now from this point, we can factor out the r1 and r2s. So we'll have r1, r2 multiplied by the cos of the argument theta 1 plus theta 2 plus I sine of the argument theta 1 plus theta 2. And this is the product of z1 and z2 in modulus argument form. So we can see then now the modulus of z1, z2 is exactly the same as the modulus of z1 multiplied by the modulus of z2. And the argument of z1, z2 is exactly the same as adding the argument of z1 plus the argument of z2. So these are really important properties that we can use when we multiply with complex numbers. In the next video, I'm going to show you how we can use this when we multiply and divide with complex numbers in modulus argument form. Thank you for watching. I hope you found that useful. If you did find that helpful, please like and subscribe, and you can download the full lesson and worksheet from my website, mrmathematics.com. There's a link in the description below. Thanks again, and take care.